all right, or whatever you put up there. So there's an inversion layer with cold below full of pollutants. Warm up here and clean, and the air can't get up. That's the inversion layer. How many of you have been flying in an airplane somewhere and came down through it? You saw it, right? How many of you have seen inversion layers? Look down and you see brown. Inversion layer. It's inversion layer. All right? Photochemical smog, really bad. There's 2 ozones in the world. The polluting ozone is created, as I've already described, by having nitrous oxide, which is a combustion pollutant, react with sunlight. All right, that's the bad ozone. There it is, photochemical. Where's our good ozone, just to make sure we understand each other? Where's our good ozone? Way down up in the atmosphere, about 50,000 feet high. That's our good ozone. It's created by sunlight too. What does it do for us? Ooh, that's right. It blocks out UV. Thank gosh. Blocks out UV. What's happening to our good ozone? It's thinning away. Yeah, due to Freon and other CFCs. Which CFCs? You stopped at the beginning. Now there's plenty of them. All right, so there it is. I will show you LA's air as an example for because it has ozone. These are plots of different pollutants on a sunny day and on a cloudy day. The LA Times quit publishing these charts, so I had to use, well, I'm using one here from 1993, not that long ago. The other pollutants come right across, but the solid line is ozone. This is carbon dioxide, that's sulfur dioxide, but that's ozone. On a sunny day and on a cloudy day. So the ozone, if the sun is above the clouds, is not being made. And when it is made, as soon as the sun goes down, so if you're a runner or you're out there doing athletics on a team outside, should you be doing it in the morning or afternoon? Yeah, morning's best. Look at that. A lot of you are athletes. And here's your problem. Worse in 1988 than it is now. But this is an example of regional New England smog coming out of the industrial areas of Pennsylvania and New York, coming right into Boston. Look at that. Your air. Wow. Mommy! But it's gotten better. It's gotten better. Massachusetts is testing, watching, observing. Here from 1994 to 2007 at Lynn, Massachusetts, looking for these, and measured in parts per billion, these aerosols that are all benzene, toluene, ethylbenzene, and xylenes that are all made from gasoline and other industrial components. Coming down, coming down, coming down. So we're doing a lot. It takes good laws. It takes brave leaders. All right? And good voters. But you do have ozone here. And here for 2006, nitrous oxide, there it is. Nitrous oxide is needed to make the ozone. And during the longer days, from May, June, July, look at that. There's the ozone. So we love our summers. I asked somebody today, is winter over? They said no. They said maybe 2 feet of snow this weekend. Really?
That would be awesome.
That's one projection. I'm with you. I want that. But so here we are. But you know, this is what you get. All right, there is. It's there. It's there. All right. So a lot of things have come down. Ozone has come down. We've passed good laws. We've done stuff. But in 1971, the Clean Air Act, 1970, greenhouse gases were not even defined. Carbon dioxide was not seen as a pollutant even. And so the Environmental Protection Agency, when asked to start monitoring carbon dioxide 4 years ago, said, no way. Carbon dioxide is not a pollutant. It's not defined as a pollutant in the Clean Air Act. So the Obama administration had to redefine what air pollution was. Because look at it. Look at, these are the greenhouse gases. Let me blow up to it. Carbon dioxide, methane, nitrous oxide, and I'm losing my red light. And CFC. CFCs, chlorofluorocarbons like Freon, are used to make your refrigerators work. and they're all going off scale. They're all going. The only success here has been the CFCs, because in the early 1990s, we passed laws to control the CFCs. Because in 1985, the ozone hole was discovered, and we're blasting ultraviolet radiation on us. That is so, got everybody so attention. No one's arguing about ozone thinning. No one's arguing about the ozone hole. And the whole world came to an agreement to stop making CFCs that would break down ozone. Whereas we did it. But the old CFCs are still up there. And they cover the entire atmosphere of the Earth. They're not going away. It's a witch's brew. And we'll talk more of that. We'll have a whole lecture on it. It has plateaued off. It has plateaued off. But nitrous oxide burning in a nitrogen-rich atmosphere, carbon dioxide, nothing is stopping this. So the greenhouse gases, nitrous oxide, CFCs, carbon monoxide, how do they work? Sunlight comes right through them. And it warms the Earth. The heat has got a wavelength in the infrared region. And the CFs and the ozone and the greenhouse gases absorb that. And so the heat can't get back out. The heat can't get back out. That's good. We love our greenhouse gases. If you took out, and there's very small numbers, if you took them entirely away, the Earth's average temperature would drop by 60 degrees. So we like the little bit that we have. It's like that blanket you pull up on you at night, okay? But now, if someone threw in extra blankets, I'm really getting hot. So the heat of your body is not escaping. The heat of the Earth from sunlight is not escaping, okay? Can't get through. Can't get through the greenhouse gases. They're blocking them like the sheets on you. You see what I mean? We like the little bit, but now it's out of control. Carbon dioxide is the most effective, followed by methane and then nitrous oxide. Water too. I don't show water here because it's not a pollutant. Okay? But we like our water vapor. And you can see the effect of water. When you have a cloudy day and night, the temperature variation from day and night is small, right? When you have a cloudy day and night, the temperature variation is small. When you have a brilliant blue clear sky, it can be really cold at night and warm up a lot during the day. That's the water effect. We like our water. It's going to do, that's just humidity. But it's not the problem. So I'm not showing it here. The problems are what we bake. These small amounts, carbon dioxide, methane. Methane, I said, is even more powerful, but it is smaller in abundance, and so it's number 2. All right, so there they are. Earth's ever dropped by 60 degrees. We took them all away. I think I need a different pointer. Hold on. Let's see if this one works. Aha. Maybe. Time for a new one. All right, so we've done that. So they're all increasing. Carbon dioxide, that single sheet that you had to do it on night, and back in 1850 was 280. 315 in 1958, 338 in 1980, 385 today. In fact, I have to keep changing these PowerPoint slides every year that I give this lecture because the numbers keep going up. Crazy. And methane has jumped 2.5 times, 0.7 to 1.7. Nitrous oxide coming up. CFCs. So they're all growing. You know, the methane, we know where CO2 is coming from. That's all from combustion. Where's methane come from? Sewage plants and cows. Yeah, cows. And all, the animal industry. You like beef? How many are meat eaters? A whole lot of us. And too many. How many are vegetarians? Bless you. You're not the problem. It's us, the meat eaters. The animal industry has never been so used. We like our steaks and our chicken and our poultry, our goat. It's all out there. Oh yeah, chickens. You like eggs? Well, there you go. The chicken industry has never been as big as it is now. The cow industry has never been like it is now. All right? And so we got all these huge blocks, and they're filthy with manure. And the animals. Look, I'm from Texas. I know about cows. You don't light a match on either end of a cow. It's coming out both ends. Yeah. Crazy amount of methane. And then sewage plants treat it as well. And there's a lot of us. create sewage. All right, they're processing that stuff. So we're actually now learning that sewage plants to capture the methane and use it as a fuel. There's so much of it. There's a good thing to do. Somebody took Earth Science 105. All right? So they're all increasing, 30%, 100%. You get the idea. I mean, look at that. This is scary. Wow. Nitrous oxide. Who'd have thought? Burning in a nitrogen-rich atmosphere. So it all started, we figured it out. It already had climbed to 310 by 1958, but we hadn't been watching. And then Roger Revelle, C.D. Keeling, on top of Mauna Loa in Hawaii, looking for something else, measuring CO2, found that the Earth is breathing. It's breathing in and out. There it is. Look at it breathe. It would breathe out during the winter. And then starting about the springtime, it starts breathing in. Summertime, breathing in. And then the autumn, the trees drop their leaves. And it breathes it back out. So breathing out, breathing in and out. And look at the Earth breathe. They found the Earth was breathing. Photosynthesis all over the world. They're sitting in Hawaii, but the air comes from all parts of the world. Wow. So it goes up and down, but look at this. In 4 short years, it went up and came back, went up, came back, went up, came back. It went up and down, and never to the same place. It kept climbing and climbing. Roger goes, CD, look at this. It's never gets back. It's climbing every year, 4 years. You know, there it is now. Holy S. Look at that. It's not plateaued off. It's not turned around. Holy God. Wow. This is funny. What cartoon is this? Doonesbury. All right, this is too much pressure. No way I can answer all of these. Heads up, dude, Professor Atkins. No, Anderson. Just ask you a question. What about? No clue. I just heard your name. Well, maybe if I ignore her, she'll think I'm taking notes. Click, clack. Get your computer out. She asked you, man. She asked you again. 4 major greenhouse gases. Wait, stall her. Well, I'll Google it. Click. Professor, we couldn't quite hear the question back here. Could you repeat it? Click. I asked Zipper to name 4 greenhouse gases. Water vapor, CO2, ozone, and methane. Right. Hey, you owe me, dude. This keeps up, I'll never get through my email. Is that you? All right. And so there, the temperatures are climbing away. Look out. And there have been some reversals. Here's the Pinatubo effect right there. All right, so it slowed down a bit, but it's going crazy. Now, and there's a lot of models today. Our department here is interviewing candidates to come in and do research on this topic. We have people here already doing that. You know, do you want a job? And I've already told you about several great opportunities. And just 2 days ago, it was about water. But here's another one, global warming. All right? Choose any of those. Amazing. All right? I'm not trying to convert all of you to being scientists. I want some of you to go out there and to go to law school and become the next president of the United States or governor of Massachusetts or the mayor of Boston and just get some of this stuff done. Or go out and teach. Okay? The truth.
Is that your only option?
To Rick Perry. And for all that matter, the whole state of Texas. And the proof of the pudding, hell, if it's warming, what should the ice sheets of the world be doing? Melting. And sea level should be rising. Yeah, there it is. Wow, look at that. This is San Francisco. But, you know, and the small island nations of the world are scared. You know, the small island nations, they've only got a couple of feet. They'll be gone in 100 years. So they're all over signing agreements to the Earth summits, and we're walking away. But where are most of the world's cities? Yeah, like Boston. We're here, right? Not fooling with us. Come on. Why aren't you signing? Yeah. So in the Ice Age, sea level dropped because of all the ice. All right? Sea level dropped. Way there was the boundary, way out there. Whoa, way out there. And so, where's our shoreline? Way up here. And then, it's coming, it's about here now, and this is one model. Look out, okay? Look out, it's coming at you. Boston's gone, by the way. New York's gone. Philadelphia, you're underwater. And my toes are wet. Florida, forget it, Miami. Gators, you're out of here. Woo, woo. New Orleans, I'm sorry, honey. Oh, man, Rick Perry. Folks, now people get confused about the ozone hole. It's a different topic. All right, it's related to pollution. It's a different topic, and the ozone hole does not cause global warming. Okay? It's not blasting. You can't see it. It's not blasting visible sunlight through us. It's blasting ultraviolet light. Black light. You can't see it. All right, so it's related to human activities, but it's a different topic. We'll talk about that later. Methane. Love our cows. We never had so many cows on this planet. You steak eaters out there, you like your hamburgers? Like good old McDonald's? Yeah. Grill? Yeah. Yeah. You're going to the feedlot. And they're burping out their mouths in the bottoms of the, you know. So the carbon dioxide, we go back for 1,000 years, it had pretty well plateaued off. It had been climbing as a greenhouse gas since we came out of the last ice age. We can plot temperature, or we can just plot the greenhouse gases. Things have plateaued off, but now, look, we call these the hockey stick. Hockey players, that looks like a hockey stick. These are called hockey stick plots because they all show it. They all show that tremendous increase the Earth has never seen. Be it carbon dioxide, methane, or nitrous oxide. Look at that, and this is temperature, and here we had plateaued off. Oh, yeah, look at it now, going off scale. Here's a different variation of that plot. Here it got warmer around the year 1000 to 1200. Those of you in fields of archaeology, this is important because humans all over the world were affected by being really warm around the year 1000. We had a little ice age where Europe, everywhere, just froze. All right? The canals of Holland, famous. You go back and look at artist drawings of the canals of Holland around 1600, they're frozen most of the year. Ice skating. Look at it. But it came out of it now, so it had mostly plateaued off with just these two changes, and then boom, look at it now. All right? This is an old plot at 2004. It's 2012 now. But we just came out of an ice age. It had as many as 16 events. Temperature was a lot lower. Here was 15, and it warmed up, and here was 16, and then it warmed up, and then it plateaued off with some variation. And now, wow. Here is 13, here is 14, here is 15. So the Earth had these pulses of ice advance and then withdrawal. So we just came out of an ice age that was multiple events that we do not understand. Actually, we don't really understand. What is the Earth doing? Making all this ice and then rewarming. Crazy. So there with the glaciers, there they are now. We still have glaciers, but they're melting back. And where they used to be in the ice age, gone. This is in New Zealand, gone. Leaving a topography that no other geologic process creates. Polished rock, striated, no other process creates a surface like that, but ice. The glaciers are gone. The glaciers are gone. There's the Matterhorn. Whoa, striated rocks. Here's a great one. This is a glacier in Austria. And this is where it was in 1938. You could drive there and get out on that deck and everybody would see and watch the ice come down. Even when ice melts back. Evan had to go. Even when ice melts back, it's moving down. But look, 1938, today, check it out. Holy God, park lot's still there. Look how much we've done. Going back to 1938. Look at that. See, bud? Whoa, whoa, whoa. And the ice, that's a glacier, and then the ice caps are disappearing. The ice caps. Yeah, now it's really shrunk. The oil companies have figured this out. This is a good thing they did, they said, because now the Northwest Passage, which we could never find, Henry Hudson died trying to find a Northwest Passage. It now has happened. We've warmed the Earth so much that the oil companies are learning that they can go. They don't need to go through the Panama Canal anymore. They can go around the Arctic ice during the summer. Wow. Whoa. Ice is disappearing. It's thinning away. And who's really affected by this? Yeah, the polar bear. Yeah, I know. Right? Arctic ice is vanishing, and sea level is rising. Look out. 1999, 2004, changes. And as the oceans get warmer, hurricanes are fed by warm water. And so here's another fact. Can't pick a flower without touching the soil. Now, the hurricanes. Last year we had hurricanes like we've never seen. All right? 5 of them, and 4 of them in this one shot. Hurricanes are getting bigger. Category 5s. Were you around? Irene, Katrina. Look out. So the sun is all part of our cycle, and it has its own variations. Sun, there's the variation of the sun. It goes, has a sunspot activity. It comes and goes. We're coming off of a big one right now. That's part of our cycle. But with that, the oceans are warming. We can go north. We can go south. Do different oceans. Ocean water is warming. The air is warming. The water is warming. The sea level is rising. And it's getting hotter in the cities. This is called the heat island effect. I told you that we warmed 1 degree. To come out of the last ice age, we had to warm 6 degrees. Then we plateaued off. In the last 100 years, we've added about 1 degree, maybe 1.5 degrees. That's all it took to get us really scared, at a rate we've never seen before. All right? But in our cities, 62 average to 67, our cities all over the world, Rio de Janeiro, Beijing, are warming as much as 5 degrees because of all the asphalt and concrete. When you run barefoot outside, you run on grass and it feels cool. But what's it like to run on concrete or asphalt or the roof of a car? It's hot. We've got a lot of hot stuff, so our cities are burning up. They're burning up. Heat island effect, all right? So we've got all kinds of projections that are going on out there, and a lot of good research being done by graduate students. Watch this movie. 1892, 1900, showing average temperature, all right, normalized to 1 base, okay? 1931, moving quickly. Whoa, whoa. Global warming from 1884 to 2011. Now, the last 30 years, it's really getting warm. Last 12 years, holy God. Whoa. Rick, Perry. Wow, and who's doing it? Yeah, this is per capita, so based on number of people. So Australia gets their number 2 because it doesn't have as many people. Isn't that interesting? Or we could do around and we can plot by total mass, and then you get something else. This is by total mass. China and the developing world. But that's a whole lot of people grouped together, not per capita. All right? And this is how it'll change. That was in 1996, and it's projected by 2020 that China and the developing world, after all, they're catching up. They have that right. Wow. Whoa. So we need these kinds of studies. You want a job? Global warming, not just global warming. Take any one of these. Study the effect on species. Go study coastal areas. Study the effect of global warming on water resources. Study the effects of global warming on the forest. Go study the effects on corn and wheat and cotton. All right? Go study the effects on health. And you'll find the most susceptible are those with weak immune systems, children, and the elderly. Okay? Go study any of these. I like to go fishing. I love to fish. And a fish that needs lots of oxygen in the water. You see, as you warm the water, water expels the oxygen. As you warm the water, oxygen is expelled, and the fish start starving for air. And a fish that needs a lot of oxygen is trapped. And so the first fish to be affected, you would discover, if you went out and studied the effects of global warming on fishes, the trout and other strong fishes. Where is this mostly going to happen? Well, there you are. Okay. It'll also habitat for brown trout down to 2050, doubling of CO2. Right there it is. Go study crop production. Some places are going to see an increase, others a decrease. Look at Upper New England. Oh my gosh. Contrast to the Midwest, the opposite sides. Things are really changing quickly. All right? So, environmental considerations. If humans continue to use fossil fuels in a business-as-usual manner for the next few centuries, the polar ice caps will be depleted, ocean sea levels will rise, median air temperatures will soar. Look what we're doing. Where is that picture? That's Kuwait. Yes, good. That's Kuwait. Set fire by the Iraqis as they ran away. Well, in my hometown, I grew up with the smell of refineries. When I smell a refinery, I go, oh, it smells good. So the Clean Air Act in 1970, we admitted it in 1977. Another one in 1990. Our first Earth Summit, we did not participate in 1992. A second in 1997. We were fully involved, but we did not sign. All right? From 2001 to 2008, Bush administration pulled out from all prior commitments. 2009, the Obama, to now, the Obama administration has reopened the debate, but we have not signed. Trying to get reelected? Okay. Whoa, whoa. Oh! Oh! Wake up, wake up. Yeah, they are. They need that ice. Okay? Whoa. Santa Claus 2! A World Without Ice by Henry Pollack. You know, you want to get your presents, your parents, a really smart book. All right? That one. Read it first, and then get it for them. Okay? World Without Ice. Watch this. Sit down. This is important. Watch this show. I've asked all of you to do a PowerPoint, but it could be some other form of multimedia. Somebody really smart put this together. Got shocking images, put it to music that's rather enchanting, put up data, over and over again, pick up the pace, cigarettes, are you with me? War, pollution, what we do, inversion layer, lots of traffic, military, pollution, moving, nuclear power, whoa, cars, how we breathe and don't, Beijing, smoke, sick, military, it picks up the pace, bird flying by, that's here, that's there, smart, China, fly away birds, it's going, pollution, go, military, there we have it, look at this, yeah, atomic bombs, volcanoes, natural, it's all part of it, atomic bombs, warfare, military, warfare, fighting, burning, smart, picking up the pace, do this. I found it on YouTube. Wow. You can download this from Blackboard, send it to your friends. What a message. Become an author, publish, write about our planet, its environment, its threat, it knows you're here. Breathe in, breathe out. Wait, one more thing. I think on Tuesday we have no lecture. Because of the way you I will email that confirmation. It's on our syllabus, no lecture on Tuesday. See you Thursday, I think. Or in my office hours this afternoon.